Now I request for our first technical presentation is titled Building India's Sovereign OS Stack, Secure by Design Architecture, Trusted Ecosystems and National Certification Roadmap. To deliver this presentation, it is my pleasure to invite Dr. Hiten Chaudhary. He is a professor in Cotton University. Professor Chaudhary, may I request you to kindly to take the floor, please.
Very good morning to all of you. Actually, there's a disclaimer right at the beginning because my presentation will be from an academician's point of view. It will be a simplified version of what ma'am just now presented. You mostly pointed most of the technical stuff, and you've been working on it directly yourself, I think. In our case, in the classrooms, we teach students about operating system, various components of an operating system, and we tell them right at the beginning of the session, that an operating system is software, a piece of software that manages all the different resources of a computer. Okay, hardware resources, software resources, all the applications. So this is what we start with. Building India's sovereign OS stack. This is a new perspective. Even I was not introduced to this. I mean, when Dr. Ashok, he said that there's a workshop that is going to happen, and it will be on operating system. My domain of research and interest is mobile network security. So since security is also involved in it, it was easy for me to relate to this, but I was not introduced. This is a new kind of a perspective. We are thinking about building a new sovereign kind of operating system stack for ourselves, for our country. So what is this sovereign thing? Because in the classrooms we've been teaching operating systems only. What is an operating system? How does it work? What are different components? What is scheduling? What is semaphore? Those kind of mutation. So those kind of concepts we've been discussing in the classrooms. But here this is a different kind of a perspective. Now, there are a few things that I've highlighted there: design, evidence, and adoption. And we'll come back to this towards the end. And these are the things that we will be focusing now in this particular thing. So the main question that I want to start with is that the main central question, if we are looking at the whole problem from the country's perspective, from the national security perspective, the central question is, can India fully trust, verify, maintain and recover the computing platform on which critical services depend? Now one fine day, suppose one morning, we realize that, okay, a hypothetical situation, I know that our authentication based on Aadhaar authentication based is a robust mechanism, and I'm pretty sure that particular infrastructure works very well and is working pretty fine. But just a hypothetical situation. Suppose one fine morning we find that, okay, our authentication system has stopped working. It is not working properly. Then many services that depends on that Aadhaar authentication system will stop working immediately, and whole country will come to many of the services will come to a grinding halt kind of. And what is our capability of recovering from that? Can we recover quickly from it? And basically, when we are talking about an operating system, we should have an operating system. The main objective is not to have our own operating system. Okay, I've always been wondering that as a country, we definitely have contributed as a country hugely to the IT revolution. But as a country, have we made our own operating system, which is being used across the country or elsewhere as well? Probably we have failed to do so as of now, till this point, that we don't have an operating system which is widely used across the country as of now. We don't have an application, we don't have a programming language which is being used by all the programmers of the country. We are failing in that. But still, as a country, we are successful in contributing to the IT revolution. So, which shows that it may not be necessary for us to actually own an operating system. So suppose we have an operating system, we tweak one of these Linux distributions, we make some modifications to it according to our requirement, then we compile and build, and finally we have our own operating system. Suppose we have an operating system like that, but is it enough? Do we know every component of the operating system? Because when we build something, we cannot build everything from scratch. We will be using some API, some function somewhere or the other that has been built by someone. So do we know every component of that, of the functions that we are using while building the operating system? Can we trust all those? So is there a mechanism to verify that trust? So if there is a mechanism to verify that trust, then is it possible for us to maintain that operating system? And is it possible for us to recover from that kind of a disaster? Say suppose one of our, say suppose another system which is running on a particular operating system has stopped working, and we have recognized that, we have found out that okay, the fault is with the operating system. Is it possible for us to identify a particular point where we know that okay, this is the area where the fault is, and this is how we can recover from it? Is it possible for us to do that? So this is the bigger question. So probably when we are talking about a sovereign operating system, this is the question that we are trying to deal with. That do we have a system? Can we have an operating system, or can we have an operating system, a sovereign operating system, which is independent? We can independently use it. And if there is a fault, if there is a failure somewhere at some point, will it be possible for us to identify where the fault is exactly? And will we have our own mechanism to recover from that particular fault? Will it be possible for us to repair that fault? So that is what the objective of having a sovereign operating system is. So basically, when we say sovereign may not be an operating system that we develop on our own in the country. It is a capability basically of knowing what is inside, what is there inside the operating system, what are the components that are a proper thorough understanding of the operating system, which component works how, a proper thorough understanding of which thing, which update is working fine, and if suppose some particular update is not working, then how to replace that, how to roll back to the previous version. So if we have a thorough understanding of the operating system, that is what will make us sovereign. If we have an operating system on our own, if we develop it based on certain components that are developed by someone else, if we don't know the dependencies, which particular component is working how, then I think we will not be able to call ourselves having a sovereign operating system, even if that operating system belongs to us, or even if that operating system we have developed on our own. So basically, some definitions of what a sovereign operating system is, something that I've already said. That say suppose we have an Indian OS distribution that we have designed using some Linux distribution that we already have, and will it have its sovereign capability? So if we want to validate whether our operating system has got a sovereign capability, we have to know what is the source of the code that we have, what is the source of the operating system, what are the functionalities of the operating system, where have we got it from, what are the dependencies involved? Because dependencies means what? When we develop an operating system, develop a program, we cannot build everything from scratch. There will be some functions, some APIs, some programs, some repository that we have to download our software from. So those repositories, we will have, our software will have, our operating system will have dependencies on certain components that are developed by others. Okay, so that is what the dependency is. So we have to know what dependencies are, how we have built the entire whole thing into a package, and we have to know the provenance, where the origin of where something has come from, and there will be signatures and all those that we will be talking about, security aspects, and what repositories are involved, and what updates, and how can we recover if there is a problem. So all of these things have to be taken into consideration. Only then we can say that an operating system is sovereign. So sovereignty has multiple dimensions as well. So say suppose if an operating system fails, it may be one of these different dimensions that we have. Technical architecture, supply chain dependencies. Supply chain dependencies means if I have got a particular API that I'll be using in my operating system, where has that API come from? What is the root? Where has it come from? It must have come through a supply chain kind of. Someone must have manufactured, someone must have written the original code, and that original code must have evolved into something else, and that something else must have evolved into something more advanced, and that is what we have used. So that is supply chain dependency. Provenance is like, what is the origin? So corrective measures, otherwise we will not be. If these people that we have around us who are, say suppose they move out of the institution, those people who are knowledgeable, those people who contributed to development of the operating system, they are not here anymore in our organization. Then what will happen is, even if there is a failure, there is a then it will be very difficult for us to recover with a new set of people. So knowledge people also matters a lot. So if you talk about a sovereign operating system, okay, I mean, as I said right at the beginning, a sovereign operating system is a new way of thinking. It is not an operating system which is totally new, something new, a new technology has come. It is a new perspective. When we were learning C programming language, it was procedural programming language. And later on, when we were introduced to object-oriented programming, it was a new methodology, new way of thinking, a new way of looking at the same programming paradigm, a paradigm shift. So this is another this I found to be another way of looking at things, a paradigm shift. Because instead of having a totally new operating system, we are trying to be capable of knowing what is there inside the operating system. We want to know what each and every part of the operating system does. We want to be aware. If there is a fault or if there is a failure at some point, we should be so capable that we should be able to detect where the problem is and identify, and we should be able to take corrective measures. Only then we will be able to say that our operating system is sovereign and we will be able to be self-reliant. We don't have to be dependent on anybody else. Say suppose we have a device, I have a mobile phone, the phone is supplied by some other country, I have got that phone, the software is from another country. In a critical kind of a situation, now we know that geopolitical situation, suppose there is a war kind of a situation or some kind of a conflict, my phone stops working because the control is somewhere else, because someone else is has developed the operating system. They actually have the control of the operating system, or they know which application to shut down. So even if our government wants to do something, keep the softwares running, it may not be possible because the main key is with them, because they are the ones who are developing. So things should not be that way. We may have procured an operating system from them, but we should know how the operating system exactly works. If a particular portion does not work, we should be able to replace that portion or a patch with our own patch. So we should have that much of understanding. So that is when we can call it a sovereign approach. So nowadays it's very difficult, even if we develop something on our own, to develop something in isolation on our own right from scratch, that cannot be a very good approach. We can have things from elsewhere, but we should have a thorough understanding of things. So if we have an operating system, there are two stacks. One is a vertical stack and the other one is a horizontal life cycle. So when we are deploying an operating system, in the operating system, we can start from the bottom, root of trust. So basically what happens is, in the hardware, okay, there are some certain security parameters. Like for instance, we can have a public key, okay, of public key installed in the hardware, in the firmware. Before the operating system boots, there are some keys that can be installed in the hardware itself. Now when I try to install an operating system, the operating system or the loader will be signed by someone who the hardware trusts or who we trust. So sign means what? Sign with the private key. So when we talk about cryptography, in public key cryptography, there are two keys. One is a private key, the other one is the public key. So if I sign something with the private key, the other party will be able to validate by decrypting that with the corresponding public key. So here what can happen is, in the hardware, we can keep some public keys, and those people who are authorized, who can provide, whom I trust, they can sign the firmware or the operating system with the private key. So I can validate whether the source of that operating system is a genuine source or not by using the public key. I just decrypt that and then see whether it matches. There will be some hash values and all, so we'll be able to validate that. So that is what we can do. So root of trust is what? The trust comes from the bottom. Even before the operating system loads, there should be some kind of security credentials stored in the hardware itself. So it should come from the bottom. So after that, we will have the hardware components, and then we will have firmware and kernel and platform services. There are different kind of services that will be there. And on the top, we will have the applications. So this becomes the main pillar, the main infrastructure, security infrastructure of a sovereign operating system. So we should have knowledge of each and every component. How the trust is flowing from bottom to top, we should have a clear idea of it. And then at the horizontal level, at the application level, the applications go through a cycle. Initially, where has the source come from? What is the source of that application? We should have a proper idea of the source. and then how it was built, the provenance, the initial place where the source, the text, the code and all those originated, who has signed it, what is the repository that was used, and the proper knowledge of the updates. Then we should be able to monitor, and if there is a problem, we should be able to recover. So this is a life cycle of the applications that constantly flows at the top. So all the applications that we have has to go through this life cycle, and time to time those applications have to be updated as well. So from hardware to applications, where the trust begins. So basically that hardware, firmware and boot trust before the OS starts. So this I have already mentioned. So even before the operating system starts, there should be a trust that should be instilled right at the beginning. So the security credentials that will be installed in the hardware will enable us that. Then so next is like say suppose in the operating system firmware itself, we have got some security credentials installed. We have our public keys and all those installed there. Then at the time of installation of the software, only those softwares will be installed that are verified, that are authorized. So how do you verify? By using the signatures. Use the signatures to verify, because you'll be able to use the signature because the public key will be there in the firmware or the hardware itself. So using the public key, you'll be able to verify a signature which is signed by a trusted party. So you install softwares which are signed by only trusted parties. And after that, time to time what happens is there's something called measured boot. So basically any application that is running, okay, when you install a particular application, because in an operating system there will be many applications that will be installed. You need to have a proper account of which applications have got installed in your operating system. So how do you keep an account of it? You install, and after installation, you create a hash out of it. So a hash value is something like a function that takes in a random amount of text, and it processes the text and converts it into a fixed size digest. It's suppose a 128-bit value or a 256-bit value, and the process is irreversible. So every unique combination of text can be hashed to a single message digest, which will not match with any other. So if you hash every bit of function that you are installing in your operating system, and if you keep a record of those hashes, then what will happen is, if there is a third party who wants to validate whether the applications that we have installed are the correct applications that are authorized, then they will be able to check with the hash value that okay, compare, and if the hash values are same, then you know that okay, these are the correct applications that have got installed. So and then you attest it basically is what, again, using those hash values only, whether you are in a consistent state or not. So you'll be able to prove your consistency. You'll be able to prove that okay, only the applications that are allowed are installed. And say suppose in spite of that some problem happens, then you should be able to recover, and we should be able to roll back to the previous good state where the system was there. So roll back to the previous state. Say suppose a fault has happened, so immediately what will be the immediate action before even you patch up the whole system? Move to the previous working state. And one more thing is that kernel security. So these are some of the approaches that you can follow, and that when you follow these approaches, you may call that your operating system is a sovereign operating system. So I think in this workshop, the discussions, the deliberations that we are having, it will not mean that after knowing all of these, it will not mean that we will be able to develop our own sovereign operating system. It will be kind of an awareness. We will know that okay, what a sovereign operating system is. I think it will take some months, some years for us to actually have our own sovereign operating system. But this awareness, we may all be involved in some way or the other. Say one of you may be involved in a procurement in your institution or your organization. You now need to know, okay, I'm taking the operating system. What are the features that should be there in the operating system, so that we are moving to that sovereign concept. So that is, this idea will help us to move towards achieving that sovereignty at one stage that we are looking towards. So if we only have an idea of what is the sovereign operating system, only then we will be able to deploy a sovereign operating system at scale. Because If one institution, if C-DAC knows or people at Ministry of Information Technology knows, that will not be enough. We have to deploy a sovereign operating system all across the country. So that means the awareness, the level of awareness has to be at scale. Everybody has to have an idea of what a sovereign operating system is. So in that kind of an operating system, again, there is something called kernel, the core of the operating system, and we reduce that core of the operating system to as minimum level as possible. Like for instance, suppose we organize a big function, and in that function, which say suppose where the control to the mic is, where the control to the entry gate is, who gets entry to the program, everything, there will be a control to main key aspects of that event that you are organizing should not be with everybody. Should not be with a person who has come to the event to sell popcorns. If you give that access to him also, then there will be problem. We want to give access to only few people, so that if certain measures has to be taken, if there is a fault or if there is a problem, we immediately can reach out to those people, 3 or 5 people. Okay, let us take the corrective measure. If you know that everybody has got access to the main functionality of the event, then you don't know where to go to. So that's why if you keep that main control as a kernel, there is something called trusted computing base. Then what will happen is you'll have a good control of the operating system. If there is a fault or something happens, then you'll be able to immediately take measures. So that key component, those trusted computing base, those core codes, should be kept at minimum. Key functionalities like memory protection, that one application is using a memory, another operating application should not use the same memory at the same time. Privilege separation, everybody will have different privileges, read, write and execute privileges. So that part should also be kept to this trusted computing base. Then reduce the attack surface. So if you have, main control is with only a few people, then the chances of fault or chances of attack will be less. Because if it is with many people, something may get compromised anywhere in the world. System call and device restrictions and access policy control. So who has got access to what? So that part also, these are key operations. So these should be kept with the kernel, with the trusted computing base. So if you have this kind of approach properly, then also we are contributing to that software and we are contributing to the overall knowledge of how the operating system is working. And one more thing, when it comes to trusted services, say suppose services related with identity, services related with cryptography, key management, audit, policy, secrets and all these. So these kind of services, these are key services. And these key services will be used by different applications. Say suppose I've got 30 or 50 applications installed in my operating system. And all these applications need to have these services. They need to have the identity, they need to have cryptography. So if we allow each of these different applications to have all of these services, then all of them will have their own mechanism of, delivering these services. So that's why what we want to do is, we want to have these services at the core with the operating system only. And whenever these services are required by any of the applications will get these services, cryptographic services, key management services from the operating system. So this could be another approach. Otherwise, there will be redundant efforts, redundancy will be there, everyone will have their own kind of arrangement for these services. So this could be another approach. Then as ma'am already pointed out, supply chain. So supply chain with regards to the software. So when a software or an application is getting supplied, where is it coming from? The developer, we should have an idea of the repository, what are the dependencies involved in the software, what other applications were used in building the software, and at the time of testing. And there is something called BOM, so bill of material, software bill of material, means what any software that is being used in the operating system or in developing the application, there should be an inventory of that. So if you have a proper inventory, when you deploy a hardware, if you in your organization, if you have an inventory of hardware that are used in your applications, then suppose something goes wrong. Suppose you hear from somebody that there is a fault and this fault is with this particular hardware, this model, this thing. If you have a proper inventory, immediately you know that which hardware is being used in which part of your laboratory. Immediately you'll be able to replace that hardware. Or say suppose you know that okay, there is a vulnerability with one particular software or one particular application or one particular API. Now if you have an inventory software bill of materials, that is what it is called, it is just an inventory of software. So if you have an idea of which API has got the fault and which are the applications where you have used that API, if you have an idea of that, immediately you can take necessary measures because you know where it is. But if you don't know where have you stored what, then you will not be able to do anything. So your software supply chain is also a part of the attack surface. So if you know where the softwares are coming from, if you have a thorough idea of what is happening where, if you have a proper inventory that you are maintaining, if you know which repositories are being used for developing your software, then what will happen is you have a thorough idea about your operating system, and if there is a fault, you will be able to take corrective measures. So these are some of the inventories: software bill of management materials, then cryptographic bill of materials means which cryptographic functions are you using in your application. If you have a thorough inventory of that, if suppose sometime like someone finds that okay, there is a flaw with one and it requires updation, you know where this particular functionality or operation is being used. So you'll be able to replace that with a upgraded version. Similarly, hardware bill of management. So what hardwares are you using? Okay, and then we should be able to say if you take a portion of the software, you build it or bring out a hash out of it, and independently you take that software again and then bring out another hash of it. You can compare the hashes and you can validate whether this software is same as the other one. Similarly, by the way, how much time do I have? Okay, just 2-3 minutes more. Okay. So another way that you can do is like while you are updating when you are deploying some update in your operating system. Your operating system requires some update. So what you can do is you don't update the entire all across country-wide. You don't do the updation. You do the updation in a small little cohort. You see how things is the operating system behaving consistently, and are the applications that are running on the surface of the operating system, are they working well? So if it is working well for a little amount of time, then you deploy it at a wider scale. So that can be another approach. So these are the approaches that will be required if you want to call yourself independent, self-reliant, sovereign, and all these kind of words that you want to use in terms of operating system. These are some of the approaches that we can take. It is not necessary that we need to have our own operating system. So similarly, all the applications that we have, the applications should run consistently. If I have an operating system, we have upgraded to a new operating system, but our applications are not working properly, then will also be a problem because government systems cannot update all the applications immediately, cannot update all the hardware immediately. Even if we have a new operating system, it should work consistently with the hardware facilities and the software facilities that we have in the organizations. So there is something called secure by design as well that Dan has already pointed out. I will not go much into details. So secure by design is right from the beginning when you are procuring the hardware. From that time onwards, from the awareness of the keys, key credentials, cryptographic keys that you have in the hardware. So from that point onwards, we have to think about security. So that is what is security by design. And next is the certifications and all those. So one thing that I want to talk about certification is certification always is based on certain criteria. When an organized certifying agency certifies you, it will tell you that okay, so suppose for example, there is a safe locker where you keep your documents safe, and if you keep that locker inside fire for 10 minutes, then the document will be safe. So that is only 10 minutes. If it is 11 minutes, it may burn. So if you may not live in the illusion that okay, my document will be safe forever. If you read the certification properly, you will find that it is written out there that if your document is inside that safe and if that safe is on fire, then your document will not burn only for 10 minutes. So you have to be aware about the certifications. You cannot think that okay, my document will be safe forever. So again, awareness in terms of the certifications are also important. So I think I have taken enough time. I had 15 minutes time only. So these are certain things that were there in the slides. And last point is that human infrastructure is also important. If you train a set of people, you have to value them. If those people are there with you, only then till that time you can feel that sovereignty. If those people leave you, then that sovereignty does not exist anymore, because these are the people who have the understanding. So this is my final slide. The takeaway that we should be able to build the right architecture, prove that the security, whatever security claims we have, there should be evidence, and we should be able to adopt it at a scale. So last sentence is that the real measure of a sovereign OS is not whether every line of code was written in India, it is whether India can understand what is running, verify what it received, decide what may change, recover when something gets wrong, and sustain the capability. So a thorough understanding of the operating system will be more useful towards making us sovereign rather than having our own operating system, and we don't even know what components were used in building those operating systems. Thank you.
Thank you very much, Professor Chowdhury, for the valuable presentation. And ladies and gentlemen, and we shall break for lunch now. We have arranged lunch in the top 7th floor in the same block, and we shall come back and begin our afternoon program at 1:30 p.m. Thank you. So there are lifts available on the right side when you exit from this auditorium.